Now, when I say simple harmonic motion, first thing you understand, in case of simple harmonic motion, we have two cases. One can go for like linear SHM, linear simple harmonic motion, and angular SHM. Okay, usually the question will revolve around these two. Linear SHM is a case of spring mass system, where you have a spring, a mass is connected. If you displace it from the mean position, it will start oscillating. Similar way, angular SHM, you take a simple pendulum. If the bob being displaced from the mean position, it will also start oscillating to and fro with respect to this mean position. Now let's talk about this one. This is at mean position, you displace it, maximum displacement, and then definitely it will not stop at the mean position, it will compress to the other side. Yeah, if I have to give some angle with respect to, because we have seen that oscillatory motion is something which is represented by a wave. So when it is at the mean position, this is 0. When it reaches the extreme, this value can be written as 90. Then what happened? Object come back to the same initial point, this point, which is going to be pi. Then it goes to the other side, the extreme position, which you can say it is going to be 270, and then it come back to the same initial point. You have to say this is my one complete wave. So this is how the angle can be written at different points. So mean position, which are the angle? 0, pi, 2 pi. For two extreme angle, if we talk about it, is 90 and 270. Got it? Okay, now what I'm going to do, you have written that position. It can be written as y equal to a sine theta. Now look here. That means if you plug the value of 0, pi, 2 pi, whichever value, the value of sine 0, pi, 2 pi is 0. If you put the value of theta as 90, sine 90 is 1. So y value will look like a. And if you put the value of theta as 270, sine 270 is minus a. So this is the way. So see, by using this equation, you can calculate the position at any place. If you put the value of theta as 30, 45, 60, even in between, you will get the value. Okay, but that value will always be written in terms of capital A. Yeah. If I go for velocity, now these are also sometimes the question is where the velocity will be maximum, where it will be minimum. I will again take help of the same equation which we have derived, that v is equal to omega under root a square minus y square. You already know that the value of y which we have written above, I'm going to use that value. When y is 0, the velocity at the mean position will be written as omega a. Correct? Wherever the value of y you will plug as a or minus a, remember the velocity value will come out as 0. What does it indicate? This formula simply tells you that if you find the velocity in case of simple harmonic motion is always maximum at the mean and it is minimum at the extreme.
Okay.
It simply indicates that. Similar way, if I go for acceleration, what is my formula? A equal to minus omega square y. Again I have the value of y. If you plug the value of y as 0, that means the value of a is going to be 0. So understand one thing, velocity is maximum at the mean, but acceleration is taken 0 at the mean, and that is the reason your net forces are 0 at the mean position. Okay?
Okay.
But when you go for the extreme, like wherever you go, if you put y is equal to a, acceleration will come out as minus omega square a. Understand something, acceleration value and a value, acceleration is coming negative and a value is positive. When you go to the other side, y is equal to minus a, minus will make it plus. That means when acceleration is positive, displacement is negative. acceleration and displacement will never have a same sign. That is something which you can see it over here. Okay, and one more thing, acceleration is maximum where it is maximum at the extreme position, and at the mean position it is 0.
Okay.
Now energy one we have proved. Now when I am going for energy, let's say we are writing potential energy first. Elastic potential energy. Formula we have derived it as half m omega square y square. Y value is 0 here, and the y value exists at the two extreme point. So both the places you will see the potential energy is going to be maximum like this. See, your object potential energy is going to be extreme, or you can say object potential energy will be maximum where at the extreme point. So when you see this energy graph and you plot your potential energy for minus a and plus a point, and remember the graph should be maximum at this point and minimum at the mean position. Similarly, if you go for kinetic energy, do you remember how we have written kinetic energy? Half m omega square a square minus y square. Correct?
Yeah.
In that case, if you notice, you will see this is kinetic energy, which is half m omega square, like that. Okay. When I am writing the value of kinetic energy value, wherever the y value will be a or minus a, that place it will be 0. But where the y value is 0, you will write it as like this. Because it simply tells you one thing, that your kinetic energy is maximum where? At the mean, and extreme should be minimum. So graph look like this. This is kinetic energy. This is potential energy. And if I have to talk about then how you can conclude that what is going to be total energy? Total energy, no matter where you calculate, everywhere it should be max. So you can see that the sum of kinetic and potential, if you do, my value of total energy everywhere is coming out as half m omega square a square, which can be simply represented by a straight line, which is the product of these two. So the entire oscillation which we have seen, or which we have derived the various formula, it can be concluded like this. So in this graph you have all the value. You have your position, you have your velocity, you have acceleration, you have elastic, kinetic, total. So whichever the value examiners say to calculate, you can simply calculate accordingly. Got it?
Yeah.
Okay.